Well, hi, everyone. Thanks for joining us today for IAM Online. This is Dean Woodbeck with InCommon and Internet 2. And you can see the topic of today's presentation and the speakers on the screen. I just have a couple of things to go over. First, you will notice at the bottom of your screen in Zoom, there is a button that says chat. In order to see the chat, you have to click that button. And then when you're in the chat, if you pose a question, which we will use the chat for question and answer, there's a drop-down menu. Make sure that you pose the question to everyone and not just to the panelists. That'll be one of the choices. IAM Online is a monthly presentation brought to you by InCommon, Internet 2, and the EDUCAUSE Higher Information Security Council. So without further ado, I will introduce you to Albert Wu, who is the Federation Service Manager for InCommon, and he will kick off the presentation. Albert?
Thank you, Dean. Hello, everybody. Thank you for joining us today for what I think is a really exciting announcement and discussion of an upcoming service from InCommon. It is the PerEntity metadata distribution service. I'm also very glad to join Nick Roy, Dave Shafer, and Shannon Roddy today. And we'll be going over the service's history, origin, the project timeline, and the progress to date, and what's happening next. We will also talk about how the metadata service works, its architecture, both in design and its hosting configuration, as well as a discussion on security and business continuity considerations for the service. So, before I begin, as Dean mentioned, if you have any questions throughout the presentation, please feel free to use the chat window to ask your questions. We will hold the questions until later on in the presentations, and as opportunity arises, we'll answer them. So with that, I'm going to get started. In the past 10 years, InCommon has gone through a very dramatic growth. I don't know if most are familiar with InCommon's history. In 2008, InCommon had just about 200 entities in its metadata. And as of last count in this month, we had well over 4,500 in the InCommon metadata. And if you then add the global entities in the federation, global federations, we're now looking at over 9,000 or nearly 9,000 entities in our metadata aggregates. That's a huge growth in the span of 10 years. With that growth and success, we are facing an increasingly difficult issue, and that is in the current metadata aggregate distribution strategy, which takes everyone's metadata and collects it in one giant XML file and distributes it to each IDP and SP. There are several scaling difficulties. The first is that an error in any of the entity descriptor can cause a global outage to the federation landscape. The federations across the world have largely mitigated this problem by validating the metadata before it is published, though that is still a concern. Secondly, and this is still ongoing, and that is as the metadata aggregates larger, it is slowing down the system startup times for IDP and SP software. And in some cases, that's causing the software to time out during startup and therefore causing outages. And because of the large file size, it is also increasing the memory requirements for the IDP and SP software and systems running them. For smaller organizations, that actually has reached a point where it becomes a blocking constraint for them to be able to fully participate in federation. Because of these scaling issues, in around 2014, a working group sponsored by InCommon Technical Advisory Committee started looking at ways to mitigate and scale the metadata distribution across the federation. The metadata distribution working group came up with several recommendations, including a pilot study to explore the feasibility of PerEntity metadata protocols. And that led to the formation of the PerEntity Metadata Working Group in 2016. And the working group came up with a second set of recommendations, including adopting the MDQ protocol and creating a pilot PerEntity metadata distribution service, and as well as begin preparation for implementation and operations in the InCommon Federation. Since that point, InCommon has been working on that pilot program, as well as building out the technology and infrastructure necessaries to run this operation. And I'm glad to announce that coming this spring, we will be launching a technology preview of this PerEntity metadata distribution service. And the intention is that by summer 2019, we will be launching that into live production. And to tell you more about that is Nick Roy, Director of Technology and Strategy at InCommon.
Thanks, Albert. Next slide, please. So as Albert mentioned, the core requirements for the production PerEntity metadata service were defined by that TAC working group in 2016, which was led by Scott Coranda with the help of David Walker and lots of members of the community. And those high-level requirements were that we maintain the security of metadata and particularly address things like man-in-the-middle attacks by maintaining the existing practice with signing SAML metadata and introducing the use of TLS. And that was actually introducing TLS was something that we then took and actually did in our existing metadata distribution service over a year ago. The service should have an uptime of roughly 4 nines on a monthly basis, a latency of no more than 200 milliseconds for about 99% of the queries coming from the Internet 2 network, and then monitor the performance of the service from different locations around the globe and make that information publicly available to participants and others. Next slide, please. So thinking about this service, obviously security and availability and performance are the core concerns here. So I mentioned that we had introduced TLS. We'll continue to use TLS for metadata distribution and continue to sign metadata, both the aggregates and the individually assigned entities. And we're introducing a hardware security module, which Shannon will talk more about, in order to do that signing securely. The availability of the service is obviously critical. Authentication from clients could be blocked if the service isn't up. So we've chosen to go with a commercial content distribution network, Amazon CloudFront. We did a survey of the SLAs for the major CDN providers, and none of them go beyond 3 nines. And it would be somewhat infeasible to achieve a 4.9 level of uptime by doing something like bridging CDNs or building our own. However, we do have data to suggest that Amazon is greatly exceeding its written SLA over the last 6 months or so. Their number of outages have been right around the level of 4 nines. We will be providing geographically distributed monitoring. Right now, we're using Pingdom to do that for our initial work on the service. I'll get into a little bit more about why we're still kind of shopping around for other options, but we're looking at other things. Links to the monitoring information will be provided in our production service documentation, so you can see that for yourself, and that will be publicly available. Dave will get into more about the architecture of the service, but we're very pleased with the performance. We're seeing less than 100 millisecond latency with larger than 99% of the queries from at or near the Internet 2 network. Next slide, please. So this is a graph that Chris Hubing and James Babb put together. And so Chris actually tested from the Internet 2 network, and then Babb tested from an Internet 2 connector. And the curves on this graph were effectively identical across both of those locations. You'll see that when metadata is cached at the edge cache, performance is extremely good. And even when it's uncached, we're still meeting that basic SLA. Next slide, please. So a little bit of a note about why we're shopping around beyond Pingdom. You'll notice on the next slide that Pingdom shows a significantly higher response time, higher latency than what we've measured. We think this is probably due to the way that it measures. It rotates around to different locations, and so things may not have gotten into the edge cache at those locations. It waits a while between checks in that same location, and it is obviously not directly connected to the Internet 2 network. But we'll continue to look at other options, and Shannon is actually doing some investigation as well as James Babb. Next slide, please. And then we get to security. So the current InCommon metadata signing key was generated on March 30th of 2004 and has been in use since then. It's time not only for a new key, but for a larger key. So as part of the transition to PerEntity metadata, we need everybody to change where they're getting their metadata from. And if we're asking them to do that, we might as well ask them to use a new public key to verify the metadata. So we'll be doing that as well. Next slide, please. We spent quite a lot of time analyzing costs for the service. We wanted to make sure that we delivered the service in a way that met expectations, but was, we're making good use of participant money. So we knew what the basic requirements for the service were. We designed an architectural pattern to meet those requirements, and then did a cost analysis. And we discovered that the vast majority of the service components are quite inexpensive in our chosen technology platform, which is Amazon Web Services. However, the most expensive part of the entire service is the HSM. It's roughly $1,000 a month to operate, but that's not much compared to running a network of, say, a couple different HSMs on premises. So it's a good investment in both our future using cloud-based technology, and it gets us out of having to directly manage those HSMs. Next slide, please. So as Albert mentioned, we'll be doing a technology preview. We'll be first targeting people who are currently using our MDQ beta platform, which was something that Ian Young had developed for us and has been in use for quite some time. And we'll ask those people to switch to the technology preview in the coming months. We'll expand the scope of that technology preview over time, right up until we deliver the production service, and at which point the technology preview will remain in place, and will actually take the place of the existing InCommon preview aggregate where we have historically introduced new metadata features. So that will be sort of the test place, and everybody can use that if they want to try out new things. Next slide, please. So it's going to take a while. You can imagine that having every single metadata client in InCommon, as well as the education and ops team, switch from the old metadata distribution service to the new one and use the new signing key is going to take some time. A lot of communication, harping on people, looking at reports, figuring out, who to target next in our communication plans. So the plan is that we'll bring up the production service in June 2019. We'll start communicating to people to switch, pointing them at documentation, and then over the next 6 months to a year, we'll ramp down use of the old MDS. Eventually, we plan to retire the old legacy metadata signing process, which will allow us to not have to have 2 people in a data center manually signing metadata once every business day. At that point, we can start thinking about things like signing metadata more frequently, signing it on weekends and holidays, et cetera. Next slide, please. Okay, so with that, I'd like to introduce Dave Shafer, who is the DevOps manager for Trust and Identity Services, and he'll be talking about architecture.
Thanks, Nick. Welcome, everybody. Thanks for taking time out of your day to join us. I see a question. HSM means AWS's web service. So this is AWS's cloud HSM product, if you want to learn more about that, which is actually hardware with the AWS management layer on top of it. So as we approached this service, we started designing a new metadata pipeline in the cloud, essentially. So What it looks like today, this is the prototype we built out, and actually we're just putting the finishing touches on the technology preview, which looks just like this as well. So today it starts by consuming the public metadata aggregate that we already publish, but in the future, as that process moves into the cloud, it'll be integrated just within the cloud environment instead of having to retrieve the aggregate from on-premises. So we have a Docker container using the metadata aggregator code, communicates with the Cloud HSM to sign all of the metadata entities. And then the container pushes those out to an S3 bucket. So that's the that encapsulates the left side of this diagram, the signing and publishing process. So now we'll go on to the next slide. Let's talk about the other half. So we'll start on the far right side. So when an MDQ client, for example, like a shibboleth provider, makes a request, an MDQ request, that's received by the content distribution network, in this case, AWS CloudFront. And it does a couple things with the request that it receives. First of all, it passes it through a client request normalizer. And this is a Lambda at edge function working with CloudFront. And because MDQ clients can express those requests in a few different ways, that function normalizes all of the variations so that the entity gets cached at the edge using one normalized representation. The other thing it does is once it's normalized that request, it's got to, if it doesn't have the data in its cache already, then CloudFront has to retrieve it from S3. So there's another function, this is the origin request translator, and basically it translates the request for the back end that we're using, which in this case is S3. So that dictates kind of how paths have to be structured and so on. And then finally, it retrieves the object from S3, and then CloudFront presents it back to the MDQ client. So that is that. I think we can go on to the next slide then. So we tried to keep this a pretty modular architecture, and every component is wrapped with component tests and with good unit tests within the code. So for example, the signing container, that consumes a signed metadata aggregate and produces the signed PerEntity metadata. So we're using a variety of static code checking and things like that, sort of orchestrated with Docker Compose, so that we can develop that signing container, test it in isolation, and know that it'll integrate with everything else as it's supposed to. And likewise for the two Lambda at edge functions. So the one in the middle shows that there are different ways that MDQ clients can express those entity IDs. Specifically, they can make different choices about percent encoding in those URIs. So that function normalizes the request inside the event that it receives and then returns that normalized request. And then the third function, the origin translator. So in both the cases with the Lambda functions, those are using Node.js, using Mocha as a test runner, and we're looking at adding even more static code analysis, things like ESLint. But just good test coverage has helped us to iterate on this stuff quickly, which is kind of one of the keys going forward. And let's go to the next slide. In addition, we have the whole system wrapped with an acceptance test suite that we built using something called Robot Framework. Some of you might be familiar with. It's Python based. This was my first time using it, and I like it. I think I won't say that this is necessarily a tool we're going to use a lot, but it's still interesting to me. What I really like is that it can translate a system like this into basically nice report output showing that all of the tests are passing. So again, this is something that allows us to iterate quickly as we're developing the system, because we can always test and make sure that the behavior stayed the same. The other thing I'll point out on this slide is that I have those components in the top row that are blue, and then the components on the bottom row that are purple. So the purple components are those things that would get shared by, I'll back up. The blue line represents kind of the metadata pipeline. What's significant there is that we can stamp out that pipeline multiple times in different deployments. So we can have our production deployment, we can have staging and development deployments that we're working on. For a test federation, it could have its own pipeline. And then those purple components are the ones that get shared by all of the pipelines. And then if we go on to the next slide, how this all gets configured. So we're using Terraform to build all of the components, and which is vastly simplified in this diagram. So what it's actually creating behind the scenes, there's a lot of stuff going on in terms of Amazon virtual private clouds and the subnets and security groups and identities that we have to manage and so on. So Terraform makes that much easier, especially for multiple deployments. Now the Cloud HSM, that is one thing that requires some additional manual configuration, but that's not something we have to touch often. And that is it for the infrastructure. So I'll hand it off to Shannon Roddy, who's the security lead for Internet 2 Trust and Identity. Shannon?
Thanks. So I'll be talking some about the HSM and some of the security controls around the sign key, et cetera. So we're using the AWS Cloud HSM. It's been validated to FIPS 142 level 3. Obviously, we care about ingress and egress of network packets and such to the network that the HSM lives on. So those networks are going to be very tightly controlled. From the signing container to the HSM, the communications are encrypted end-to-end. And we have privilege separations for operations that are related to the HSM and that particular VPC environment. So AWS provides various libraries and extensions to interact with the HSM, both PKCS11, so like if you're doing OpenSSL operations, it will talk through PKCS11. And then there's a Java crypto extension that you can also use for Java software. Ian Young extended our metadata aggregator, or the shibboleth metadata aggregator. Thank you much for that. And also, anytime the signing container talks to the HSM, it cryptographically verifies that it's actually talking to the correct HSM via a certificate that's signed with an offline internal CA before it even sets up the end-to-end encrypted tunnel. As far as signing performance, with a 4096-bit key, it takes about 15 milliseconds per signing operation. And so what that means is all approximately 8,500 entities can be processed in just over 2 minutes. So we can do a complete run on the aggregate in about 2 minutes. Also, we have security controls in place such that any operations regarding key operations or any kind of user account operations, those will require quorum. So we'll have to have a number of people sign a token in order to do anything related to that. Those people don't necessarily have to be sitting in the same room, but you have to reach quorum to do any critical operations to the HSM once we've loaded the private key in there. Next slide. As far as disaster recovery, we could have generated a key on a hardware HSM and marked it non-exportable. So then there would be hardware protections wrapped around export of the private key, the signing key. However, this locks you into both the HSM solution and, by implication, the vendor. But it also trusts the vendor random number generator on the HSM. So we chose not to do that. we don't want to be locked into any one particular solution. And we also want to be able to trust the key generation. So we will be generating 2 private keys, well, 2 key pairs in a key generation ceremony, both 3072 and 4096, 4096 to future-proof ourselves. And the long-term storage, so the disaster recovery scenario for that, or for those private keys, the keys will not be stored in an unencrypted form. So they'll be put away in, the copies will be put away in safe deposit boxes in geographically redundant locations. And if somebody were to compromise that safe deposit box, they wouldn't actually be able to compromise the key because it's AES encrypted. The decryption key to decrypt the encrypted private key will also be sharded. So there will be multiple custodians of multiple pieces of the decryption key. So again, in order to decrypt the private signing key, we will have to reach quorum. So a minimum of 4 custodians of the shards for the encryption key will have to basically make their shard available to decrypt the private key. Next slide, please. So for the key generation ceremony, we're going to be using brand new dedicated shrink wrapped hardware that's never been touched before, other than for manufacture. We've done some testing on duplicate hardware to make sure that the hardware random number generator on that particular hardware is of sufficient quality, quote unquote, for generating random feeds of data. We've tested it against the FIPS 140-2 tests using just a standard Linux tool, RNG test. We've also used an open source test suite that's been around for, I think, about 15 years called Die Harder. When we do the actual key generation, it will be done in a secure area and completely offline. So no wireless, no Bluetooth, no LAN cable. It'll be unannounced as far as location and time, so that, hopefully we don't have any eavesdroppers. The key will not leave the generation ceremony in an unencrypted form. So immediately after the key is generated, we will encrypt it. And we'll have a documented chain of custody, 2-man rule, etc. At all times when we're transporting the key to and from long-term storage, and then also to load it into the HSM. I already mentioned we'll be generating 2 keys. So 3072 will be used for production. We will have the 4096-bit key available in case we ever need to roll over to future-proof ourselves. Also, as mentioned before, we'll be retiring the old signing key in process as part of the migration to MDQ. And I think that's it for me.
Okay, thanks. We've got a number of good questions here, so I'm just going to go through those from the chat, and then people should feel free to ask any additional questions they have in the chat. The first one was from Scott Cantor, and he says, by HSM, you presumably mean AWS's Amazon Web Services web service into an HSM, not an actual hardware solution. Shannon, do you want to take that one?
Yeah, so it's actually a hardware HSM that was basically designed for multi-tenancy. It's like I say, it's met FIPS validation, for whatever that's worth. I'm pretty convinced that it's a pretty secure solution.
Thanks. Let's see. John Morton says, is your ECS container running on EC2 or Fargate? Dave, do you want to take that one?
Yeah, sure. So it's currently running on Fargate just because Fargate is wonderful because they provide the Docker hosts basically and manage that for you. So if you can get away with it, it's really wonderful. That said, we are still evaluating whether we can use it in production. So we're looking over AWS's compliance statements about the ECS flavors. So I think the jury's still out in terms of what final production will look like. If we have to fall back to EC2 instances, it's not the end of the world. That's something we're already working with internally, so it'd be pretty familiar to us. I don't know if anybody else has anything to add on that. Otherwise, I think that's it.
Okay. Michael Geddes has a question about the people that will possess the key shards, the shards of the AES key that is used to encrypt the signing key, and wants to know if those people will be people that all report up through the same person. The answer to that is effectively likely yes, if you consider the same person to be at the Internet 2 president level. Likely, however, in reality, that will be split up between people in different divisions of Internet 2, reporting to different VP level people. So there will be some in an operations group in one part of the organization, others in a different part of the org, most likely.
Yeah, and I'll add to that. We've sort of coalesced on the number of people required to reach quorum and the total number of shards, but the names assigned to those shards is still not written in stone.
Yep. Let's see. So I'm just getting back to the list here. John Morton says he understands that the underlying hardware that's used to back AWS's Cloud HSM is single tenant. Not certain that that's the case. My understanding is that they had custom hardware designed. It's probably based on single tenant hardware, but again, they've got attestations that it's, on a per tenant basis, it meets FIPS 142 level 3. So. Let's see, Sherry Shipman asks, what's the process of deciding what I want my PerEntity aggregate to contain from the user side? Do I give a whitelist, a blacklist, a combination, or what? Is it something different than that? So effectively, PerEntity metadata disposes with the concept of an aggregate. We will still be publishing aggregates. It's actually required by the MDQ spec that you provide at least /entities endpoint where you can go in and get all the entities that the service knows about. And that will look like our production main aggregate. But clients that support MDQ should basically be configured to retrieve metadata, individually assigned entity descriptors on an as-needed basis and then cache those for some period of time. And we'll talk about that in the documentation for the service. So all your IDP or your SP needs to know is that it's got a base endpoint that it uses that implements the MDQ protocol, and then when it sees an entity that it's interacting with that it hasn't seen before over some period of time, it would go and fetch that metadata, verify the signature, and then use it to configure itself. Does that make sense? All right. Okay, so Jerry says, yes, that makes sense. And Michael Geddes asks, I'm not seeing how this overall architecture supports the running of campus level MDQ. Will this be addressed? So Paul Caskey built the signing container that we're using, and that signing container actually contains a web server which is configured to serve PerEntity metadata per the MDQ spec. So you could actually, and that container is in our enterprise GitHub repo. Anybody can go and pull that, and you could use that to serve local metadata, and that is the basis for the container we're using to do the signing.
Yeah, I'll just add on to that. It's the same guts, but instead of serving it off of a single web server, we push it into a CDN to serve the metadata globally. So yeah, the pieces are definitely there.
Additionally, over time, it's likely that, as we're going through things like the code review that we've got scheduled coming up here, we'll probably start to decide what pieces of this we feel comfortable with sharing more widely. and there's a potential there that things like the Terraform configurations, or at least some of them, might possibly be made public, but we'll have to be very careful about that. Okay, let's see, there's another question here from John M. Thank you for your Fargate answers. You probably already saw, but Fargate seems to have checked off a lot of the compliance regimes as other AWS services. Shannon, do you want to talk a little bit about that? Shannon or Dave?
I was just going to say that's exactly the information we're looking at right now. But thank you.
Yeah, there was also a question about shards and redundancy. So the idea with the shards is that the decryption key for the long-term stored key will be basically divided up amongst people. So we're saying that minimum of 4 people to reach quorum, but then there's some redundancy built into the shards over and above that because we have more than 4 shards, and it requires 4 of 6 is our minimum right now. We may decide to generate more than that, but 4 of 6 is what we're talking about right now. So those 6 shards will be distributed amongst people, and there's going to be policy and procedure wrapped around the storage of those shards. So they'll actually be very widely distributed and basically inherently redundant.
Thanks, Shannon. Paul Fardy asks, does MDQ with InCommon affect inter-federation or international metadata flow? Not directly. So we will be, when we have this service in production, we will ask the EdgeGain operations team to go get our export aggregate from the new service. That will have to wait until we've moved most of the old signing stuff out of the old environment and into MDQ, which will happen after the production service goes live for most customers. So that means that when, say when we've got the Federation Manager running in Amazon, we'll be able to produce that export aggregate using the MDA tooling. And at that point, we'll stick it at an endpoint in the MDQ service, and I'll just send a note to the EdgeGain OT. For people consuming the metadata, that way it will look exactly the same. It's still an aggregate that goes to EdgeGain. There is a larger implication, I think, for federations that are members of EdgeGain, and that is that EdgeGain itself, the metadata in EdgeGain is so huge now that the EdgeGain MDS, it's probably less critical for the EdgeGain MDS to look at MDQ, but all the participant federations in EdgeGain should be looking at doing an MDQ deployment because if they are consuming EdgeGain metadata and redistributing it to their participants as they should be, their metadata is going to have the same size problem that ours does today. That implies that it might be a good idea to think about running a global MDQ service. It would be ideal for everyone who's part of a federation that participates in EdgeGain to be able to get their metadata from the same place. And if we're building a globally available, scalable service like the one that we're building, that's a pattern that could be reused to help more widely distribute PerEntity metadata globally. Let's see. Okay, so Michael says, so you can distribute the shards outside of Internet 2 staff to have resiliency for management issues for obtaining a quorum. This could address the do this or you're fired issues question. So,
yeah. Go ahead.
No, I was just going to say Shannon.
Yeah, I mean, I'm happy to entertain those kinds of discussions if that's a strong concern. We're, at this point, we're flexible still on the number to reach quorum and the total number of shards. It doesn't have to be decided until essentially we do the key generation. So sure, happy to entertain discussion on that.
I would say that at some point, I think we need to trust the organizational structure and the transparency built into InCommon to believe that that situation would never arise. And if it did, it would be something that participants would hear about before it happened. I think everyone here takes their job incredibly seriously when it comes to security. And, you know, somebody ordering somebody to go and give them an unencrypted version of the signing key so they can do malicious things is something I have a hard time believing would ever happen here.
Also agree.
All right. Are there any other questions, comments, et cetera, for the group before we adjourn? Okay, Tom Barton says, will non-InCommon entities in EdgeGain also be available through the new MDQ service? I.e., an entity does not need to go here for InCommon entities and elsewhere for non-InCommon entities. Tom, that's correct. We will, every entity that you find in the current InCommon metadata, including all of those that we import from EdgeGain, will be published in our production MDQ service. So if, and our metadata has always been publicly available, even to the point where there are cases where companies or other people running quote federation deployments or deployments of federated software who are not members of InCommon have actually consumed InCommon's metadata in the past and used that in lieu of actually joining InCommon when they're dealing with, like, say, an IDP bilaterally. That will continue to be the case with MDQ. We're not putting in any additional access controls, and we will always publish all of the InCommon metadata and all that we import from EdgeGain. All right. Well, thank you for your time, and I'm going to turn it back over to Dean for some wrap up.
Yep, Albert, if you could advance the slide, please. There is an evaluation. I also posted this in the chat, but if you could take a couple of minutes and complete the evaluation, we use those to improve future IAM Onlines. And next slide, please. These are a few upcoming events. We have a InCommon fee change open office hour tomorrow at 2 p.m. Eastern, and you can click on that link to get the details. The next two IAM Onlines are highlighted there in terms of the topics. And I want to highlight the last item, Basecamp, which will be a training and learning opportunity for folks who are relatively new to InCommon, relatively new to the Federation, and or relatively new to identity management. And you'll be hearing a lot more about that in the next month or 6 weeks or so. And I see one other question. Okay, thank you, Ann. Yeah, I can't get to the web server right now, but I'll post the slide deck as soon as the webinar is over, along with a link to the recording. So with that, we will give you 16 minutes back in your day. We want to thank everyone for joining us today. Thanks also to the presenters, Albert, Nick, Dave, and Shannon, for a good job explaining the MDQ service. Thanks a lot, everyone. Have a good day.